A Harvard astrophysicist has just accused NASA of repeating an official mantra.
The object in question? 3I-ATLAS, the interstellar visitor you've been following. The controversy centers on 13 mathematical anomalies that, when combined, have a probability of less than 1 in 10 billion of occurring by chance, at least according to one assessment. Avi Loeb argues the math points one way, NASA insists the object looks and behaves like a comet. You know the basics. Now let's examine what the numbers actually reveal and why this has the scientific community divided. Loeb ranks his anomalies by probability. The strongest have odds below 0.004%, 4 in 100,000. Here's the most striking. On March 16, 2026, forecasts place 3I-ATLAS at roughly 53.445 million kilometers from Jupiter, a distance Loeb points out aligns astonishingly closely with Jupiter's Hill radius, calculated to be about 53.502 million kilometers for that date. That numeric near match is the foundation of the first anomaly. For those unfamiliar, the Hill radius is the boundary of a planet's gravitational sphere of influence, the region where a planet can stably hold satellites and where placing objects requires minimal fuel for orbital insertion. Across the full diameter of Jupiter's orbit, this precision corresponds to roughly a 1 in 26,000 probability for a random interstellar approach to land at that exact boundary. Think about that. An object traveling for billions of years through interstellar space, arriving at essentially the optimal orbital insertion point. That's just the first anomaly. The second is geometric. The retrograde trajectory of 3I-ATLAS lies within about 5 degrees of the ecliptic plane, the same flat plane where our planets orbit. For an object coming from random directions in interstellar space, the approach angle should be essentially random. That alignment makes planetary encounters far more convenient than they'd otherwise be, and convenience in orbital mechanics is not the same as coincidence. Third, the anti-tail. During July, August, and November 2025, multiple images and observations showed a sunward jet, a glowing extension ahead of the object's direction of motion, persisting across months. Some researchers note that large dust grains and particular particle dynamics can create forward extensions. But Loeb asks a pointed question. Why would such a configuration persist steadily for months unless something was maintaining it? The persistence of that feature is an observational oddity worth probing. Fourth and fifth are compositional anomalies. Spectroscopy indicates an unusually low water fraction, around 4% in some measurements, far below what we expect from typical solar system comets. Instead, there appears to be a relative overabundance of nickel compared with iron, a ratio more reminiscent of industrial nickel alloys than of known cometary materials. Polarimetric measurements also report extreme negative polarization values unprecedented among catalogued comets. These are the physical peculiarities that have planetary scientists and spectroscopists paying attention. At NASA's public briefings, the agency's position has been clear. Based on imagery and behavior, the object resembles a comet, and the evidence points toward natural causes. That stance, succinct, authoritative, prompted Loeb to respond sharply, accusing commentators of relying on an official mantra instead of engaging fully with the statistical argument. He even quoted Sherlock Holmes, "There is nothing more deceptive than an obvious fact." The result is a public scientific tension between observational interpretation and statistical inference. Not everyone reads Loeb's list the same way. Penn State astronomer Jason Wright and others have analyzed the anomalies and conclude that only a subset, the nickel abundance, the extreme polarization, the low water content, and the rapid brightening, are truly troubling to comet specialists. In other words, these might be the signatures of a new oddball class of comet, rather than evidence of anything engineered. Wright's point is that anomalies drive new comet taxonomy. They don't automatically imply agency. Loeb's counter is statistical. If these anomalies are independent, the probability that they all occur together is the product of their individual probabilities. Single anomalies are interesting, but many low-probability events happening together can rapidly produce a vanishingly small chance of a wholly natural explanation. History reminds us to be humble. Science once dismissed water on Mars and thought exoplanets were exceedingly rare, but statistics force us to confront how unlikely combinations should change our priors. What happens next is observational, and it comes in two important windows. The first is December 19, 2025, when the object makes its closest approach to Earth, about 270 million kilometers away, an ideal opportunity for ground-based spectroscopy and polarimetry to capture high-signal data on jets and composition. The second is March 16, 2026, when 3I-ATLAS has a predicted close approach to Jupiter, near the Hill radius. If Jupiter's environment registers unexpected bodies or perturbations then, it could be decisive.
What measurements will decide the debate? First, high-resolution spectroscopy of any jet material. Sublimation of ices produces a characteristic velocity profile and molecular signature. Engineered thrusters would likely show narrow-band, high-velocity exhaust and unusual elemental abundances. Second, continued polarimetry and photometry to see if the extreme polarization and brightness trends persist or evolve. Third, targeted imaging of Jupiter's Hill sphere during the March window to detect any newly co-orbiting objects or unexpected fragments. These are concrete, testable observations, precisely what science demands. Consider the possible outcomes. If spectroscopy, polarimetry, and imaging all converge on natural explanations, complex dust physics, unusual but natural metal ratios, transient fragmentation events, then we have discovered a new type of interstellar comet that challenges formation models and expands our understanding of material from other star systems. If, instead, we find spectroscopic lines incompatible with sublimation, pulsed or directed emissions, metallic ratios matching manufactured alloys, or objects in controlled orbits around Jupiter, the implications would be profound and demand a very different scientific response. Either result deepens our knowledge. The mathematics itself doesn't make claims about origin. It quantifies improbability. The interpretation still sits with the observational data. That is why transparency matters. Public release of raw spectroscopic and polarimetric data would let independent teams test models, reproduce analyses, and either corroborate or refute extraordinary claims. Scientific consensus builds when data is shared, methods are transparent, and alternative hypotheses are fairly tested. 3 questions for you. Can a 1 in 26,000 precision relative to Jupiter's Hill radius really be coincidence? Should NASA and other agencies release all raw spectroscopic data publicly so the wider scientific community can weigh in? What specific evidence would convince you one way or the other? A clear spectroscopic signature of engineered exhaust, discovery of artificial fragments in Jupiter's Hill sphere, or a robust natural mechanism that explains all anomalies? Leave your answers in the comments. In the coming weeks and months, we will get more data from telescopes and possibly from spacecraft already around Jupiter. If Juno or other orbiters detect pre-existing or newly arrived objects in Jupiter's Hill sphere, that will be a major clue. If ground-based spectroscopy in December shows jets consistent with simple sublimation, the extraordinary claims lose ground. Either way, this is science in real time. Observation, hypothesis, test, repeat. The history of astronomy is a history of revised certainties. We once thought certain things unchangeable until data forced a new picture. Today, the math points to improbable overlaps. Tomorrow, the data will tell us whether those overlaps were coincidence, an overlooked natural process, or something that pushes the boundaries of what we thought possible. Subscribe and follow the observational windows of December 19, 2025 and March 16, 2026, because in those dates, the next chapter of this story will be written. The mathematics doesn't lie. The question is what the mathematics is trying to tell us, and whether the forthcoming observations will let us hear that answer clearly.